We are continuing our unit on logic, and we're going to start getting into topics that are not inside the book. So it's very important that you take good notes so that you have that information in class. Also, I have some guided notes for part of this video, but there will be parts of this video that are not part of the guided notes, so make sure you also have a notebook to take normal notes on. So first, let's talk about compound statements. These are statements that are comprised of one or more simple statements that are linked or modified by connective words. Just for an example, I might say our statement might have been, Miss McCahan is my teacher. And another statement might be, I go to PNH, right? This was a statement that we did in previous videos. So I might use a connective word like, Mrs. McCahan is my teacher, and I go to Parkway North. Or in the last one, when we did conditional statements, we used if then. If Mrs. McCahan is my teacher, then I go to Parkway North. All right, so that's what we mean by compound statement. And same thing for just like simple statements might be true or false. Mrs. McCahan is my teacher. That might be true or it might be false. And same thing as the compound statement as a whole might be true or false. So if I say, if Mrs. McCahan is my teacher, then I go to Parkway North, that will be true depending on which parts of the compound statement are true and false. So in order for us to analyze statements a little bit more and consider all of our options, we are going to do what we call truth tables. Okay, so a truth table is just a table of true-false values, and we use it to evaluate the truth of a compound statement. So we're going to break that compound statement apart and look at its individual pieces and then analyze it as a whole. So first, the truth table contains all possible combinations of the truth values of each simple statement, and then evaluates the truth of the compound statement for every combination. All right, so for example, if a compound statement involves two statements P and Q, the truth table will have 4 outcomes. Okay, and we'll talk about those outcomes in just a minute. And then we're going to use these to help us evaluate some compound statements that we've already discussed. So the 4 outcomes, if I've only got 2 statements, then they could either be both true, first one's true, second one's false. I'm right here. Or the first one could be false and the second one true, or they could both be false. All right, those are all the options. And if you think about, that's similar to flipping a coin, right? If I flip a coin, the first one might be heads, right? But then the second one could be either heads or tails. But I could also switch that around, and the first one could be tails, and then the second one could be heads or tails. So there's a total of 4 possible outcomes. All right, so then let's talk about the different connectors. A disjunction, also called a union, sometimes other logic books might use the symbol U. We will be using the symbol V for logic. A disjunction is 2 statements connected by the word or. So for that to be true, it requires at least one of the statements to be true, but not necessarily both simultaneously. So for example, I studied for the test, or I got an A on the test. So when we say that compound statement, we're meaning one or the other to be true, or they both could be true. That's a possibility as well. But we want at least one of them to be true when we say something like that. Here's how that would look. So if I said, I studied for the test, if that was my P, and then, or I got an A, that was the Q, here's how we would write that symbolically. That would be P, and then V represents the or. So this is represented by V. So P or Q. So when we do that, remember all of our statements, I could have this one be true, this one be true, this could be true, and this could be false. And when we set up our truth tables, we always do it the same way. So I don't know if you've noticed this, but just to keep everything organized so we know that we've got all the possibilities, and then we can compare our tables as well. We will always do the first one like this: true, true, false, false. And then for the Q, we would alternate true, false, true, false. Okay, if we all do it that way, then we can all compare our tables and make sure we're not looking at the wrong line or anything like that. So here's how we would do that. This is just the setup. When I do this, this is just all the possible truth values. So now over here is where I'm going to evaluate the compound statement. So if I have both statements are true, so that means if I studied, so I studied or I got an A on the test, if both of those things were true, then that would be true. Our statement would be a true thing. All right, so let's say you studied, but you didn't get an A in the test. Well, that means that either one of those, one or the other, happened, so our statement is still true. In this situation, the first one is false. So you did not study, but you did get an A on the test. Well, then the statement of you studied or you got an A on the test is still true. So the only time this is false is this last one. So you didn't study, you didn't get an A on the test. So when we say I studied or I got an A on the test, that's false. That's wrong. That's incorrect. So this is what we call the truth value for our compound statement. That's the disjunction, the union, or. The conjunction is two statements connected by the word and. Let me move that over. And. For the conjunction to be true, it requires both statements to be true, not just one or the other. Okay, so for the word and, we represent that. It kind of looks like A without this part. All right, so it looks like an upside down V. All right, so for this one, so I'm going to use the same P and Q values. So this is still my P, this is still my Q, but now I'm going to join them with and I'm using that symbol. So we would say P and Q. So I studied for the test and I got an A on the test. All right, so let's look at the truth values for that. So reminder, setup. The P, the first one, is going to be true, true, false, false. And then for Q, it alternates true, false, true, false. So I got an A, I studied and I got an A. That would be true. If you studied but you did not get an A, then that statement is not true. That's false. If you did not study and you got an A, that statement that we said for both of them happening is false. And then if both of them are false, then obviously then that's false. So the only time and is true is when they're both true. Remember in the previous video, we said that we had conditional statement and we used this symbol to represent that. We had the converse where we switched the Q and the P. We had the inverse, that's when we took the conditional and negated it and we said that was a tilde. Okay? And then the contrapositive is when we switched and negated. And biconditional had those double arrows. So let's talk about a few of those right now. The conditional. So if we wanted to do a truth table of the conditional, we have to do this premise. A statement is false only if we can prove it to be false. Otherwise, it's true. All right, so I'm going to list true, true, false, false, and then true, false, true, false. And let's look at an example statement. So if you get an A, then I will give you $1. Okay, so what we mean is, am I going to keep my promise? So if you get an A, that's true, and I will give you $1, that's true, then yeah, I kept my promise, didn't I? So that is true. So the second one, if you get an A and I did not give you $1, then I broke my promise, didn't I? So I kind of lied to you. All right, when I said that, if you get an A, then I will give you $1. Okay, now here's where most people get messed up on it. So let's say you didn't get an A, but then I still gave you $1. Well, some people might say, well, that's lying because you didn't keep your word. But just for argument's sake, we're going to say, well, that's still, I didn't break my promise. I still gave you $1. So that's still true. Even though it's not quite the condition I set it up to be, I still kept my promise. All right. And then false, false. If you didn't get an A and I didn't give you $1, I didn't break my promise. That's what I said would happen. And I just followed through on the consequence that time. Okay, so here's what a conditional statement looks like. The only time it's really false is this one right here. When the condition is true, but the consequence is false. So the conclusion is false. So think about when, hey, you got an A and I didn't give you $1, that's false. So think about that when you think about conditional truth tables. All right, biconditional means, remember, that's like our definitions. So I'm going to set up my truth table. And for biconditional, we said before that they either both need to be true or both need to be false in order for us to write a biconditional statement. So I'm going to skip around here. So the only ones that are going to be a true biconditional statement is if they're both true or they're both false. I know this is the one that creeps people out, but like if something's false and then it implies false and then vice versa, then that's still a true statement. False implies false and vice versa. True implies true and vice versa. It's in the middle here that if I switch them, if I go true then false and true, that's not the same thing. So that's why those middle two are false. And we can talk about more of that if you need to in class. And then the last one we need to talk about, and these are part of your guided notes, is that if the statement is true, then the negation is false. So we typically only talk about negating one thing at a time. So I'm only going to put one statement there, so P. So I'm only doing true or false. I don't have to do true, true, false, false. So the negation of that looks like that squiggle or the tilde, P. So if the original statement is true, then the negation would be false. If the original was false, then the negation would be true. So that's how your negation table looks. So now let's move on from the basics of our truth tables and use them to do some compound statements. So now we're going off of the guided notes, and you'll need to take some notes on your own. All right, so we have these examples that we're just going to write these symbolically. So we have P is going to be represented by exercising is essential for good health. Q is eating too much causes strain on the heart. And R is going to represent good health slows the onset of aging. And we haven't talked about R, but R is just another symbol. This is when we have more than just two statements. Okay? So if I wanted to say eating too much does not cause strain on the heart, well, that's really taking the Q statement, but it's negating that, right? Because of this. So all I would do is write not Q. That's how we could represent that first statement symbolically. All right, the second one, exercising is essential for good health. That's the P part, right? Right here is P. Then we have and. Do you remember what we used for and? That's that upside down V. And then good health slows the onset of aging. This part is R. So if I wanted to write that symbolically, I would write P and R. Number 3, if exercising is not essential for good health. So that's the P, but it's negated, right? So that's P, but we have the not there. And also notice that it started with if. So when you see if, look for then. That's gonna mean that we have that arrow. And then we have good health does not slow the onset of aging. So then that's gonna be the R. But again, I have the does not, so I have a negation. So all of that, in order to represent that, we're going to have not P, so squiggled P. If then means arrow, and then does not R, so not R. I wrote P, but I said R. Sometimes they will put parentheses around that just to be clear about where the not goes. So just be aware of that. And then our final one, exercising is essential for good health. So that is the P. That's P. Or, so we have a connector. Or eating too much causes strain on the heart. That's Q. That part is Q. And then we have another connector. Or good health slows the onset of aging. So then we have, let's see, what haven't I used? R. So notice I have two connectors because I had three different statements. So that's going to look like P or Q or R. So that's a very long compound statement. All of these are just ways that we can simplify statements or analyze them using symbols so that we're not writing these very, very long statements all the time. Okay, now let's go backwards. So if I had a statement like this, so the symbol, then I need to know what does that symbol represent. So once we get done with doing all these symbols, we need to know what does that mean. So notice this first one, I have all this stuff in front of the arrow. Okay, so the arrow means I'm going to have if-then. So I'm going to start my statement with an if. And then before I do the then, so I'm going to have a then, but before I do the then, I'm going to do P and Q. So I'm going to do a P and Q. And I know you guys don't have the infinite cloner, but that's okay. You can pause. If exercising is essential for the good health and eating too much causes strain on the heart, then, so now I can do then because I'm at the end of the parentheses. I just did Q. So now I'm ready to do the R. Then good health prevents old age. So that's a compound statement going from symbols to the meaning. And then let's do another one. So not P. So if I look at P, here's P. Exercising is essential for good health, but I have to do not. So exercising is not essential for good health. Or, the V means or then I have not Q. So here's Q. Good health prevents old age, but then I have to say does not. So let me put a does down there. Does not prevent old age. And then we could get rid of that S. All right, so that's taking the symbols into the words. So now let's take a look at a compound statement with a truth table. All right, so notice in this statement, this whole compound statement, the only variables I have are P and R. So I'm going to put P and R. And just like P and Q, I'm going to list the table, true, true, false, false. And then the second one is going to alternate true, false, true, false. Now, in order to analyze this whole thing as one piece, I'm going to break it into its little parts. So I'm going to look at the part just before the or, the not P. So I'm going to put at the heading not P, because I can do negation of P. That's pretty simple. So I'm going to look at this column right here, and I'm just going to do the opposite of that. So here in this first line, it's true. So I'm going, here, I'll do lines across so we can keep everything. I don't like this line. That way we can keep everything lined up. All right, so the opposite of true is false. The opposite of true is false. The opposite of false is true. And the opposite of false is true. So that's my not P. I'm also going to look at the part after the or, the not R. Again, I want to do those first, and then I'll connect those two pieces. So now I'm looking at this column, and I'm going to do the negation of that column. So the opposite of true is false. The opposite of false is true. The opposite of true is false. And then the opposite of false is true. So now in my last column, I'm ready to do the entire compound statement. And really all I'm doing is looking at these two, but I'm thinking of the or. So let's go back to what did we say about or, the disjunction? When is that true and when is that false? Or is going to be true as long as at least one of them is true. All right, so if I look at these two columns, the first one's false, the second one's false. I'm looking at these two right here. So I don't have at least one of them true, so that has to be false for that one. Now in the second line, the second one's true, so I have at least one true, so that means that statement is true. And then the third line down, I have at least one true, and then the fourth line down, I have at least one true. So this would be my result of this compound statement. So what does all that mean? That means if I have these original statements and I know that these truth values, I can connect them to that final. So if I said, okay, I know that, what were our things for? Exercising is essential for good health, but I also know that good health does not prevent old age. So that would be true then false, right? That would be this line. So then I can look at this one over here and say, well, my statement then would still be true. The statement that you made. Let's do another one. Let's do the not Q or R. So again, I only have two variables. I have Q and I have R. And so I'm going to do true, true, false, false. And then for the second one, I'm alternating true, false, true, false. Okay, so I'm going to do my not Q. And that's so I can just look at this first one and then do the opposite of that. So false, false, true, true. All right, so now I'm ready to do the whole thing. So I'm going to do not Q or R. All right, so now I'm looking at these two columns and I'm thinking or. All right, so I need at least one of them to be true for me to put true. Otherwise, I'm going to put false. So this first line, again, I'm just looking at these two. I have at least one true, so that's true. Both are false in the second line, so that's false. Both are true, so that means my statement is true. This one I have at least one true, so that one's true. So this would be my final outcome for that statement. So let's save some of the rest of these for in class so we can do some together. Yeah, especially that one. Do you notice how this one has 3 variables? So we'll do that one together. That one gets very large.